Hi friends, I am Dr. M. Kumar. In this video, I am giving some introduction about the machine learning techniques used in automatic detection of voice disorder. In this video, the main objective or motto of designing this video is to introduce or discuss about the present details analysis of various voice disorders and machine learning techniques used so far for developing automatic systems. In this video, consisting of voice disorder, introduction to voice disorder, automatic detection of voice disorder, feature extraction techniques, feature selection techniques, and various machine learning approaches used for voice disorder detections are clearly discussed in this video. Speech is the human's genetically determined behavior pattern, and voice is one among its subsystems. Recently, the study of the vocalization is coined as vocalogy. Normal voice is the acoustic product of pulmonary air pulses interacting with the larynx that sets the adduction of true vocal folds and produces periodic and aperiodic sounds. Often, multiple abuses vocal habits, commonly referred as a vocal hyperfunctions, results in voice disorders like aphonia, that is nothing but a complete loss of voice, or dysphonia, that is a partial loss of voice. And to define the voice disorder is anything that deviates the quality, pitch, loudness, vocal flexibility from the voice of similar age, gender, and social groups. The changes in the lifestyle and professional demands have increased the public awareness of the need for voice care. Citizens now make frequent visits to laryngologists and voice therapists for maintaining vocal health. During such visits, it is common to undergo invasion tests like video or laryngoscope or straboscope, which are both difficult to administer and expensive. In reality, the effect of voice disorder are not life-threatening. Untreated voice disorder can significantly impact social, professional, and personal aspect of communication. As the clinically, the foundation of voice therapy is to optimize laryngeal and supralaryngeal muscles tensions during voice production in an attempt to improve vocal efficiency and also enhance the resolution of vocal fold lessons. In communication science, disorders are classified into five categories. Hence, voice disorders are classified into speech disorder, language disorder, social communication disorder, cognitive communication disorder, and swallowing disorder. Hence, there are basically five types of classification of voice disorder according to pathology. Pathologists has categorized based on hyperfunctional and hypofunctional vocal folds. In this category, there are basically eight types, and finally, it is ninth is an undiagnosed form. In this first form is the structural lesions like vocal nodules or vocal polyps. Second one is inflammatory conditions like acute laryngitis. Thirdly, it is injury based. Fourth one is systematic conditions, for example, hyperthyroidism and hypothyroidism. Fifth one is non-laryngenic aerodigestic disorder consisting of reflexive disorder and bronchitis among others. Sixth one is psychiatrist or psychological disorder, which are functional voice disorder and mutism. Seventh one is neurological conditions, for example, abductory plasma, abductory and spasmodic. Uh, Eighth one is other disorders like muscular tensions and dysphonia. Automatic detection of voice disorder can be designed and developed using machine learning algorithms. Here, basically, we require the voice data needed to be pre-processed and converted into a set of features before applying an machine-level language algorithm. Hence, a given set of voice data in audio files need to be labeled manually by experts as representing healthy or a pathological voice. Then the raw audio data in each files are divided into short frames and each frame is processed to extract the features from it. The set of features extracted from all the frames are considered as input for the machine learning algorithms. The data set is divided into training and testing sets by randomly selecting the observation belonging to both normal and pathological voice. The training set is used to develop the machine learning modules and testing set is used to evaluate the module. During the evaluation process, the classification accuracy is computed. This classification accuracy is taken as a matrix for assessing the performance of various automatic detection of voice disorder systems. And this is the block diagram where how the steps each steps of the system has to be computed are designed in each level. In building a automatic detection of voice disorder, feature extraction techniques is the first step in any voice disorder detection system. In this step, the given voice signals are converted into representative acoustic features using various digital signal processing techniques. Hence, now we are going to introduce some most popularly used techniques for acoustic analysis and feature extraction in the related area. The most important is acoustic analysis, male frequency scepter coefficients, linear predictive coefficients, discrete wavelet transforms, glottal flow, single parameters, signal parameters. Features of acoustic analysis is the measurement of sound information in voice. The result of acoustic analysis could be used for measuring the severity of voice disorder. Some of the measures associated with acoustic analysis of voice signals are distress in the fundamental pitch period and peak amplitude, vocal noise included in the signals, cycle to cycle wavefront variations, average frequency characteristics, and transition characteristics of the signals are computed in the acoustic analysis. In male frequency septal coefficient, it is commonly called as MFCC, is a standard method for feature extraction that makes use of the knowledge of human auditory system. The general steps for extracting the MFCC features for a single frames are computation of discrete Fourier transformation coefficients. Next, the filtering with the melt spaced triangular filters, and then the computation of sub-band energies, and finally the computation of discrete cosine transformation coefficients, which gives the MFCC values for each single frames. Another most popular feature extraction technique is LPC, that is linear predictive coefficients. In linear predictive analysis, the first step is to estimate the source signal using inverse filtering. After that, the source signal is used to compute the spectrum. The computed spectrum is used to study the energy distribution in both normal and pathological voices. The number of linear predictive coefficients is one of the key factors of the LPC analysis. in order to determine the formant peaks, because removing the effect of the formants from the speech signal will provide an accurate estimation of the source signal. Discrete wavelet transformation. The discrete wavelet transformation is nothing but a DWT, can be used in variety of signals processing applications. It is discrete in time and scale. The voice is a time variant signal and sometimes needed to be converted into frequency domain for the analysis. The DWT is capable of performing a joint time frequency analysis and also the analysis of high frequency characteristics of the pathological voices. Hence, it is useful tool for voice disorder detection. The DWT coefficients may have real values, but the time and scale values used to index those coefficients are integers. Another technique is glottal flow signal parameters. The glottal flow signal can be obtained by performing an inverse filtering of the voice signals, which consisting of eliminating the influence of the vocal tract and the voice radiation caused by the mouth and preserving the glottal flow signal characteristics. Here, the time domain parameters that can be extracted from the glottal flow signals are closing phases, opening phases, open quotient, closed quotient, amplitude quotient, normalized amplitude quotient, quasi open quotient, and speed quotient. While measuring in a frequency domain parameters in a glottal flow signals is identified the difference between the hormones and hormonic richness factors are computed. In automatic detection of voice disorder, after the feature extraction, feature reduction is a pre-processing steps in machine learning. The main reason for this is to eliminate repeated and inappropriate features in order to improve the efficiency of the system. The selection of highly useful features from the dataset will reduce the complexity of the learning phase and thereby improve the ability of the classifiers to generalize. Some of the most commonly used dimensionality reduction techniques are PCA, that is the principal component analysis, LDA, that is the linear discriminant analysis, or genetic algorithms, higher order singular value decomposition, relief, minimum redundancy, maximum relevancy, fishery discrimination ratio, that is FDR. These are the major feature selections techniques are applied in designing a automatic detection of voice disorder systems. After the feature extraction and feature selections, the machine learning algorithms plays a major role and it is an important algorithms we have to apply. In research work in the area of the pathological voice detection and classification started in early 1980s, when pattern recognition and machine learning techniques were not much advanced and popular. There are few works carried out using basic techniques like distance measures, vector quantization, and statistical analysis, and so on. In recent days, the machine learning algorithms are popularly used for detection of pathological voice based on the computed acoustic features of input signals. The machine learning techniques categorized into hidden Markov model, Gaussian mixture model, support vector machines, and artificial neural network, decision tree, linear classifier, k-means clustering, and combined classifiers. These are the most commonly applied on the voice disorder systems. Hidden Markov model is used to model the spectral variability of the each speech sound using a mixture Gaussian distribution. HMM acts as a stochastic finite state machine which is assumed to be built from a finite set of possible states. There is an hidden during evaluation, and each of those states are associated with a mixture of Gaussian probability density function. Another technique is GMM. There's a Gaussian mixture model is used to model the probability distribution of feature values which are continuous in nature. The voice acoustic measures are continuous, hence it is suitable to model the voice characteristics. The GMM parameters are estimated during training using exception maximization, iterative algorithm, or maximizing a posterior algorithm. Another technique is SVM. SVM has its roots in statistical learning theory and has shown promising results in many practical applications, which works very well for high dimensional data. The basic idea here is to construct a hyperplane with a maximum margin that separate the features of different classes by representing the decision boundary in represented as a set of support vector. ANN is nothing but an artificial neural network algorithm works based on the concept of biological neural network in human. It consists of set of neurons connected to each other, and the output of one neuron can be fed as input to another neuron. The neurons are arranged in layers, that is input layer, hidden layer and output layer, also referred as a multi-layer perception, where the number of neurons in each layers and total number of layers depends on the type of the applications are important. Another technique is K nearest neighbor classifier. KNN is one of the simplest machine learning algorithm, also called as a lazy learner. For a given test data, it uses distance measure to decide the KNN in the trained data. The class label of the KNN are analyzed to make the final decision. Decision tree is a tree whose internal nodes are test or input patterns and the whole leaf nodes are categorized of a pattern. It is constructed based on the information given in the training set data. Linear classifier is a feature extraction technique based on empirical model decomposition, using which one can extract the meaningful information from both time and frequency domain from the continuous speech. The advantage of using the continuous speech is that it does not require the separation of sustained vowels from the speech, which is very erroneous task in case of pathological voices. The extracted features are classified using a linear classifiers are achieved of up to a 95.7% classification accuracies. K-means clustering is an unsupervised machine learning technique in which the objects are grouped together based on Euclidean distance measure. Each cluster is represented by a cluster means and new object is assigned to a particular cluster based on its distance from cluster mean. Finally, the combined classifiers machine learning technique is applied in detecting a voice disorder. To achieve the improvement in classification accuracy, different classifiers can be combined together, referred as a multiple classifier system. It can be designed by combining the techniques involved in different classifiers into a system called ensemble design or by developing a module called fusor, which combines the output labels of different classifiers. This is the most recently advanced researchers are done using these combined classifiers. In this video, we have given the introduction to machine learning approaches for automatic detection of voice disorder. Dear friends, if you are interested to reach us, you can reach us using this telegram link or an email ID. And this is you can also subscribe to our YouTube channel HK Shiksha Academy. In this HK Shiksha Academy, weekend classes will be conducted for all competitive exams and computer science and engineering subjects. Thank you, friends. We will be meeting in the next video. Thank you.